Okay, so here's a more recent diploma question regarding shifts that's a little bit different because there's many possibilities in terms of the answer depending on which material you're choosing. So we have our equilibrium equation, and then we have the different shifts or stresses that we can cause to the system, and then based on what you choose here, we would be able to answer these two. So there's a lot of different possibilities here, but they have to still be right. So I just wanted to show an example that would go through each of the possibilities depending on what you chose, and every student could have a different answer, but it has to start with either 1, 2, 3, or 4. So if you chose number 1 and it was a hot plate, that would mean you're heating the system. So if my energy is on the right-hand side, so exothermic, and I want to heat my system, I'm adding to this energy and I need to shift away. So if you add in, shift away. If you take out, shift back. So I'm shifting away. So this would be number 1, shift towards the reactants. And then noticing the colors here, it would become lighter because it's getting to the clearless side and away from the blue side. So our first possibility is 1, 6, 7. So now let's take a look if you chose number 2. So number 2, instead of heating the system, you're cooling it down. So here's our energy again. If I'm not adding in, I am taking away. And if I'm taking away, I want to shift towards to replace it. So my shift would be towards the products, and if I'm shifting on the product side, I will be a darker blue color. So this one was 2, 5, and 8. Now if I chose option 3, I have concentrated NaCl. So we know that that's an ionic compound in solution, so Na positive, Cl negative. If we go to look and we're not directly seeing what we can add in because we don't see anything there, then instead we have to see what we can take out. And what we can take out is what we can make a solid. So Na isn't on our chart at the top as a common ion, but we do have Cl negative, which is here. If I go down to these ions, these are the ions that will make a solid with chlorine. So here, I'm going to notice I have Ag positive, which is there, and Ag positive will join to Cl negative and make a solid, which means it's leaving the system. The concentration of Ag positive is decreasing to make this solid. So you need to shift back to replace the Ag positive. So here I'm picking number 3, I'm shifting towards my reactants, and again, if I'm shifting that way, I am turning lighter. So this one was 3, 6, and 7. Okay, so I just want to reiterate, if you're adding something and you don't see it within the equation, you need to check your solubility table and see what will form that solid. Whatever forms the solid is decreasing in concentration, and you have to shift to replace it. So our last option was option 4. And if I'm adding Ag positive and NO3 negative, that shows I'm directly adding in the ion Ag positive. So if I add this in, I shift away. So this was number 4, shift towards the products. And if I'm shifting towards the products, I will become a bluer color. So here were the answers that we just went over. Those would have been the acceptable answers. And as always, if you did find this helpful, please subscribe. And if you have any other video you would like me to do, just let me know. Thanks for watching.